Hey, Miss Smith.
Okay, you guys, can you see the screen with the problems on it now? Okay. So let's see. For number 19, you're supposed to find the values of x and y. So when you look at this problem, you have the two triangles there. You know that, so it gives you the measure of these two angles. Since this one's a right angle, this one's also a right angle, okay? So you know that the interior measures of the angles add up to be 180, right? So let's see. You also know that this angle here is congruent with this angle here. So if you said, oh my goodness, my dogs are crying at me. Hang on. Did the picture go away? Okay.
Yes.
Hang on just a second. Let me try to get it back pulled up, okay? Okay, is it back now? Okay, let's try that again. So this is going to have you go back a little ways in algebra. Do you remember having to solve equations when you had two variables where you could get rid of one? Hush. Okay, do you see this new image now? Okay, so here's what I'm talking about. I just copied this in because it's easier, because it's a lot of writing. Okay, so when you see on the other picture that you have the 12x plus 4y, and you know that that equals the 40-degree angle, right? Well, you can figure out that the other angle is 50 because the interior angles of a triangle add up to 180. So if you have 180 minus 40, minus 40 minus 90, then that's going to equal 50. Okay, so that leaves you with a 50-degree angle, which is where they get this from. So now remember when you would set your two equations up, and sometimes you may have to do something to one of the equations so that you could eliminate a variable. So on this one, that's where this multiply by 4 comes in, okay? Because when you set them up like this, you have 4y and a minus y. Well, that's not going to get rid of a variable. But if you multiply the bottom part through by 4, then when you add down, it will get, or I like to say combine down because you may add or subtract. So when you combine down, that will get rid of that 4y. So then you'll be dealing with only x's here, okay? And then that's super easy to solve for x. And now we can plug that back in like they did here. Plug that back in, solve for y, and get y equals 1. You guys remember doing that now? Is it all coming back? Okay. Yeah, these made you dig deep into last year's work. And solving equations with two variables is nobody's favorite, probably. Okay, can you see that, Campbell? Okay. So for number 20, when we look at this one, we can see we have our two triangles, and we know that these two angles here are equal to each other, right? Sorry, it's not letting me write. So these two angles here are equal to each other. We can also tell that if we know these measures in this triangle, we know this angle here and this angle here, we can figure out what that angle equals, right? By saying 180 minus those. So that's going to give us 22. Okay, I know it's kind of blurry. So that's going to give us 4x plus y equals 22. And then we also know this other one would be 6x minus y equals 28. Okay. So now if we set these up, these variables here, these y's, we can get rid of those by adding down. So 4x and 6x is going to give us 10x. The y is going to go away. And 22 and 28 gives us 50. So that's going to tell us x equals 5. Now we can plug 5 back in and say 4 times 5 plus y equals 22. Okay, because we go back into one of the original equations. So 4 times 5 is 20 plus y equals 22. So y is going to equal 2. So that's it. You were supposed to find your x and your y. You're welcome. Okay, Charlotte Ann, give me just a second and I'll pull up your two also, 12 and 14, okay? Okay, so when we look at 12 and 14, we're supposed to write a congruent statement for any figures that can be proved congruent and then explain your reasoning. So when we look at 12, we know that we have these two triangles here, right? Right now, in order to prove that triangles are congruent, what we have to know is that all sides and all angles are congruent, right? Okay, so when we look at 12, we only know that two sides and one angle are congruent. We're still missing a side and we're still missing two other angles. And that problem doesn't really give us any other information about those two triangles. It gives us nothing else to go off of to prove that those are congruent. So for number 12, we don't have enough information. They cannot be proved congruent. Okay. Does that one make sense? Okay. Hey, Megan, I see your question. I'll help you in just a second, okay? So for number 14, when we look at that one, in order to prove triangles congruent, we have to prove that all sides and all angles are congruent. So we can kind of carry that over into other shapes as well. If we can prove that all sides and all angles, corresponding sides, corresponding angles are congruent, then we can say that those shapes are congruent also. So if you can imagine this, let's see, this shape here kind of flipped around a little bit, it would look just like that other one. And looking here, we have these two sides have two tick marks, right? And then here and here, they each have one. And down here has two as well. These are right angles. And then it has one line here, and two lines here. So if we compare this figure with that figure, then we can see this one, these sides, these angles, these sides, this side, and these two angles. So that's every part of this shape has a congruent part, a corresponding congruent part on this shape, okay? So you can prove that those are congruent. You're supposed to write a congruent statement for that. So remember, when you're writing your congruent statement, your order of your letters matter. So when you write this, you need to make sure that your Z would correspond with your J. V would correspond with K. W could correspond with L, and so on around that pentagon, okay? Does that make sense? Okay, good. Okay, Megan, let me pull. I worked on 19 and 20 just a second ago. Let me pull those back up, okay? All right, so can you guys see those again? Okay. So Megan, this is going to make you go back to algebra. You can kind of see my work here on the side, where you know that when you're solving equations with two variables, you can set them up like this where they're on top of each other. And then you can do an elimination to try to eliminate a variable. So in this case, we were able, on number 20, we were able to eliminate the y because when you add down with those two equations, then we can just set those plus y minus y is going to be 0, okay? So that gives us just the 10x equals 50. And then we would divide by 10 and get x equals 5. And then remember, you would take that 5 and plug it back into one of your original equations and solve for the other variable. So you'd get x equals 5 and y equals 2 for number 20. Do you remember doing that in algebra? Okay. So now number 19 is a little different. You're still going to set your problem up the same way, except do you remember back in algebra, sometimes you had to multiply through every term in the equation sometimes to get it to where you could eliminate a variable? That's what you'll have to do with number 19. So for number 19, you're going to have your 12x plus 4y equals 40. And then 17x minus y equals 50. And the way that you know that that's 50 is because you have 180 degrees for the interior angles of the triangle. You know one of them is a right angle, and the other one we know is 40. So when we subtract that, we get a 50-degree angle left, okay? So when we stack those on top of each other, well, 12 and 17 are weird. You're not going to be able to really easily get rid of 12 and 17. But if you look at the 4y and the minus y, that we can just multiply through by 4. So that's what they did here. And you get 68x minus 4y equals 200. And then you add down. So 12x and 68x gives you 80x. 4y minus 4y gives you 0. And then 40 and 200 gives you 240. And again, you solve for x and get 3. And then you're going to bring that over here and plug into one of your original equations, okay, and solve for y. So when you plug that 3 in, you're going to end up solving for y and get y equals 1. Does that help make sense, Megan? Okay, you're welcome. Hey guys, for 19 and 20, I didn't say this, but the reason that you can set those equal to each other, the equations and the angle measurements, is because of that theorem that we know that if two angles from one triangle equal two angles from the other triangle, then the third angle is also congruent. So that's the reason we were able to actually solve those problems for 19 and 20 the way we did. Okay, Charlotte Ann. So for number 8, we're supposed to say in this diagram, copy and complete the statements. So we have to figure out what YZ is congruent to, okay? You know what, I may need to see if that works. So when we're looking at this one, YZ is it's down here, right? Okay. Now, we said that the measure of angle Y equals 33. Sorry, not 33. The measure of angle Y would equal the measure of angle N, which is 124, right? Now, when we look at these two, then we said the measure of angle M. What did you put for number 6? Okay, that's right. 33 degrees is correct for 6. It equals the measure of angle X. Okay. So then, sorry. Measure of M equals the measure of angle X, right? YX. Let's see. Maybe let's try it this way. Our congruent statement is here, right? So remember, the order of these letters matters. So angle X and M are the same, Y and N, Z and L. And then you can also look at it like this. X and Z is the same as M and N. And then you could say Y and Z are the same as N and L, okay? Because remember, the order is corresponding for each shape. So Y and Z are the last 2 letters in this triangle, N and L are the last 2 letters in this triangle. So that tells us that those 2 would be congruent with each other. Does that make sense? Okay. That's one reason why it's so important to have the letters in the right order when you're listing your congruent statement, because then you can rely on that. You can go back to it, and that will tell you each different part of that is equal to each other, okay? So that way you can say X, Y, and MN, Y, Z, and NL. And then you could also say X, Z, and ML, okay, to get that last side.